we want to solve the equation sine x plus 0.36 equals 0 on the interval from 0 to 2 pi, where the interval is closed on 0 and open on 2 pi radians. So we first want to solve the equation for sine x. So if we have sine x plus 0.36 equals 0, we'd begin by subtracting 0.36 on both sides. So this gives us the equation sine x equals negative 0.36. Now from here, notice how we're looking for angles over this interval that has a sine function value of negative 0.36. We won't be able to find these angles using reference triangles or the unit circle, so we'll have to use the calculator to find our solutions. So to solve this equation for x, we would take inverse sine or arc sine of both sides of the equation. So if we take inverse sine of both sides of the equation, this would give us inverse sine of sine x equals inverse sine of negative 0.36. So on the left side, inverse sine of sine x is equal to x, and on the right side we have inverse sine of negative 0.36. Now before we go to the calculator, we need to remember that the output or the range of the inverse sine function is the closed interval from negative pi over 2 to pi over 2 radians. The terminal side of negative pi over 2 radians would be the negative y-axis, and the terminal side of pi over 2 radians would be the positive y-axis, which means the calculator is only going to give us one solution on the interval from negative pi over 2 to positive pi over 2 radians. This is important to recognize because we're looking for solutions on the interval from 0 to 2 pi radians. So now we'll go to the calculator and first verify we are in radian mode. So we'll press the mode key. Notice on this third row here, radian is highlighted. So now we'll go back to the home screen, press second sine for arc sine or inverse sine, negative 0.36, close parenthesis, and enter. So the calculator is giving us a solution of negative 0.3683 radians. But notice how this angle is not in the interval from 0 to 2 pi radians. Let's go ahead and sketch this angle in standard position. This would be the initial side. The terminal side would be approximately here. Again, this is the angle here the calculator gave us of approximately negative 0.3683. So notice how the reference angle for this angle would be positive 0.3683. An angle that's coterminal with this angle in the interval from 0 to 2 pi would be one solution to the given equation over this interval. So one solution in the given interval would be where the initial side is here and the terminal side is here. Notice how these two angles have the same terminal side and therefore would have the same sine function value. So to find this angle, which we'll call x sub 1, we could use one complete revolution of 2 pi radians and then subtract the reference angle of 0.3683 radians. So one solution would be 2 pi radians minus 0.3683, and now we'll go back to the calculator. 2 pi minus 0.3683 would be approximately 5.9149 radians. There's also another solution. Remember that sine theta is equal to y divided by r, and y is negative in both the fourth and third quadrants. Here's the fourth quadrant, the angle that we just found. There's another angle in the third quadrant that has the same negative sine function value. And it would have to have the same reference angle as this angle here, which means the reference angle in the third quadrant would be 0.3683 radians. So it would be somewhere in here, where again the reference angle would be 0.3683 radians, and therefore the second solution, which we'll call x sub 2, would be pi radians plus 0.3683 radians. So again, x sub 2 would be approximately pi radians plus 0.3683 radians. And now we'll go back to the calculator. So pi plus 0.3683 radians would be approximately 3.5099 radians. So again, just to review, one solution, x sub 1, given by this angle here, was 2 pi radians minus the reference angle of 0.3683. And our second solution in the third quadrant, where the sine function value is also negative, was x sub 2 equals pi radians plus the reference angle of 0.3683 radians. So here are our two approximate solutions. And let's go ahead and verify this by checking the sine function values for these angles. So if we press sine of 5.9149 radians, the sine function value should be approximately negative 0.36. And notice that it is. And also sine of approximately 3.5099 radians should also be approximately negative 0.36, which once again it is. I hope you found this helpful.